Now is the time, unfortunately, where I must deliver both good news and bad news. The bad news is that this is unfortunately our last session in our CLM journey. The good news is that we are closing on a topic that encapsulates the true utopia of configuration lifecycle management. Please join me in welcoming Anders S. Rasmussen, Senior Principal Software Developer at Configit. Anders will demonstrate how a shift from engineered to order to configured to order processes can be realized and managed by you.
Thank you, Tom. And let me see if I get my slide set up. Here we go. Okay. So my talk today is about manufacturing processes, or more specifically, it's about some of the challenges that our customers have when they approach Configit. So in my talk, I will look at two different manufacturing processes. One is called the engineer to order process, and another one is called the configure to order process. So what situations are we looking at? Well, for many of the customers that approach Configit, the process and the challenge actually starts at the point of sale. So this is where the end customers who wants to buy a product and the salespeople, they agree on some kind of product that is to be manufactured and delivered. So this is where we have the first challenge, because a lot of these sales processes, they are often they're partially manual and they're not assisted by proper IT tools. So what happens is that the end customer will ask a lot of questions and express requirements for some of the products they want to be have delivered. And then, of course, the salesperson will go in and say, well, here's a good idea. If you buy this, I think you should buy those other things, and explain about all these possibilities. So there's a dialogue going on between the end customer and the salespeople. This dialogue actually requires some very skilled salespeople in order to be successful. So the result of this dialogue is a description of the required product as seen from the customer's point of view. And this can be anything from Excel sheets, it can be an email, and in fact, we've even seen paper-based orders being created at some of the customers who've been approaching Configit. So my focus today is, how does this order get from sales and all the way over to manufacturing so that we can manufacture the order and then deliver it with success? Now, obviously, we need a lot of details before such an order can be manufactured. And the question here is, where does all that information come from? Now, the answer is often that the order must go through an engineering department. So here we have some pretty clever engineers, and they will manually go in, inspect the order, and then figure out how to realize what has to go into the final product. So this process here is called the engineer to order process. So let's try to look at what work this engineer has to perform. So on the manufacturing floor, we need a bill of material for the order. So a bill of material, that's a description of all the assemblies and the parts, the structure of the products, etc. So in short, you could say a bill of material actually represents the design of the product. So in a real world example, we do need more. We need CAD drawings and calculations, technical documents, etc. But for my talk today, I will look at bill of materials as being a representative of the design for the product that we're trying to deliver to the end customer. So the design of all previously manufactured products, they're actually described by bill of material. And that's a pretty good starting point for the engineer. So what the engineer would do is that he would start a search process and look at all these existing products and all the existing designs that are available. And the objective is to find a design of an existing, previously designed and manufactured product that is, in some sense similar to the current order that's being worked on. So once a design that is similar to the existing product that we're looking at has been found, then the engineer would inspect it and do a lot of calculations. And then finally, create a new design that's based on the existing design. And, hang on, I need to be here. And then finally, he would modify the product in order to come up with the design that is required so that it can be manufactured and delivered. So what are the challenges with this process? Well, at the point of sale, the sales staff is not supported by the engineer. And that means that salespeople, they might inadvertently overpromise on product functionality that cannot be delivered. So you can imagine that it happens especially for very complex products, or for instance, when new products are introduced. So overpromised functionality, it's not discovered until the engineer looks at the order, in which case it might have to be sent back for being renegotiated. And that means that there's a lot of alignment between the engineer and the sales process that simply extends the whole process of selling product. There might also be missing information when the order comes into the engineer, so he would have to send it back. And having this order bounce back and forth might actually lead to a loss of faith from the customer. So another issue is that pricing might be a challenge, especially if pricing is cost-based. So that means that the price is based on the parts required to manufacture the product. So often the engineer, he cannot get an accurate price to the salespeople until he's done a lot of calculations. And that means that if the price is more than expected, the customer might actually choose to search for alternatives, or even worse, abandoning the purchasing process. So another major challenge is the number of manual processes involved in engineer to order. So first, the order will have to be created and sent to the engineer. And here, sales might actually lack assistance of proper IT tools. Secondly, the engineer will have to find an existing manufactured product, an existing design that he can use as a starting point. And then finally, the engineer will have to do a lot of calculations. Now, of course, these calculations, they take time and they tie up valuable engineering resources. And calculations, as they're often partially manual, they might actually lead to mistakes, and we know mistakes can be very costly. So for many companies, the primary reason to move away from this engineer-to-order process is actually due to resources, because every quote requires manual attention, and that means that increased activity in the sales link will automatically imply increased pressure on the engineering link. And we know engineering is a limited resource, so boom, we can actually overload the engineering department. We don't want to do that. Of course, all companies, they want to increase their activity in the sales link. They want to sell more. And so it's easy to recognize that we have a challenge that we should address here. All this said, the engineer-to-order process is not all bad. This process is actually incredibly flexible. So it doesn't prevent a customer to ask for products that has not been manufactured before, or maybe not even invented yet. And I think this is one of the primary reasons that many companies sees this way of selling as a strength, because that's a way for the companies to be able to offer all their IP to the customers. Now, I'll get back to this flexibility later in my talk, and we'll have a look at how we can still achieve that if we approach it a little differently. So let's talk about how we can address some of these challenges that we just looked at. So one obvious approach would be to perform some of the engineering work before the point of sale, basically aiming at the ability to reuse the engineering effort for all the incoming orders. And this can be done by, for instance, creating a product model. Here it's pretty important to note that we're not trying to force the companies to be engineering-led. The objective here is to reuse information, so we avoid doing the same calculations again and again for each and every order that comes in. So a key observation here is that knowledge that we capture in a product model should actually represent all aspects of the product. So that means that besides the engineering aspect, we should really capture knowledge from everywhere, from sales, from manufacturing, service and support, how the product is installed, how it's maintained, etc. Now, big question. how do we create a product model? Well, the first very vital step is to establish a common language. This language describes the intent of the product as it's seen from all the different departments that handles the product. And we often refer to this language as the feature catalog. So the terms used to communicate with the end customers, they are captured from sales. And this is really terms that are used by the end customer to express requirements. Operations performed by the engineer, they capture technical intent. So they describe all the technical parameters of the product. And of course, we have manufacturing aspects that describe information that are relevant on the shop floor where the product is manufactured. The picture at this point is not complete because usually we have a lot of other departments that describes information, again, about things like installation, transport of the product, service, upgrade, decommissioning, etc. So this common language that we create here, it enables all the departments to communicate with each other. And this is very essential for the next step, because now we get to the really interesting part about a product model, and that's capturing knowledge. So we need to first ensure that all the sales rules are captured, and they define how the product is offered to the market. So typically, salespeople, they want to define what they want to sell, where they want to sell it, and when they want to sell it. Engineering, they define rules about how the product is designed and what the capabilities of the products are. So this, you can say, basically describes what is technically possible. And of course, we have manufacturing rules that defines the constraints that are relevant to manufacturing. So this might describe something like limitations and possibilities that relate to the product as it's manufactured on the shop floor. Now, there should be more room in this product model, but of course there would be other rules that describe other aspects of the products. Again, installation, transportation, support, etc. So once all this knowledge is created and collected in the product model, what we will do is we will publish it and release it for consumption. And that means that now we have a single source of truth that describes all the valid products that this company can manufacture. So we put this model into the point of sale and consume it there using a sales configurator, just like Sigrid just explained to us. And this configurator will interactively guide the end customer towards a configuration that we now know is valid because it's based on all the knowledge we have in the product model. And that makes the sales process a lot more streamlined, and it makes it possible to quite fast get to a valid configuration that describes what the end customer wants. So we do have one open question. How do we connect this configuration to manufacturing? Because we still need a bill of material for the order. And remember, we are trying to avoid having the engineer inspect every order. So the answer is that the modeling team, what they would do is they would consume the bill of materials from existing manufactured orders and create a configurable bill of material. So a configurable bill of material represents all the possible parts and all the possible assemblies that could be used when manufacturing a product. A configurable bill of materials, it's really just like a regular bill of material, but it's annotated with what is called selection conditions. And this is information that express when each assembly or each part should be used. So let's look at the output from the sales process as it stands right now. Right now, the configuration only represents the end customer's requirements for the product. But using the rules in the product model, the configurator can actually complete the configuration and then infer all the features that describes the engineering, the manufacturing, the service intent, etc. And this completed configuration can now be applied to the configurable bill of material. So what we do is that we evaluate the selection conditions against the completed configuration that we know is valid because we created it on the product model. And the result here is an automatically created configured BOM that represents the design of the order product. So just to recap, this BOM here is constructed by combining a valid configuration with the configurable bill of material. And now this final configured bill of material can be sent to manufacturing so the product can be delivered to the end customer. So this process here is called the configure to order process. I will end up concluding on a lot of the benefits of the configure to order process. But first, before doing so, let's just return to this notion we had about the engineer to order process that we really liked, which was flexibility. Because there has been some concern sometimes when companies are trying to go into the process of moving from engineer to order to configure to order. And that concern is, do we lose the flexibility we have in selling everything we can possibly manufacture or possibly deliver? And the answer is no, not quite. It is actually possible to mix engineer to order and configure to order process. So let's take a look at that. During configuration, there could be cases where the customer would refrain from choosing any of the available options. So basically, we can allow the customer to leave some of the options open for the engineer to find the best solution. But there could also be other cases where the customer asks for things that are simply not described in the product model. So it could be that the options that the customer wants are not available, or it could even be that the whole thing that the customer would usually describe, there's no way to put that into the configurator. So in this case, we would annotate the configuration with a note, simply accompanying the order saying, this is what the customer knows he wants, and here's some extra additional things we describe that is something additional to what the product model will offer. This result in a partial configuration, potentially with these additional annotations on it. Now, the interesting thing here is that a partial configuration can also be used to evaluate the configurable bill of material. And the result is a partially configured BOM where only parts of the BOM are solved. That means that there are still parts of this configured BOM that the engineer would have to go in and select and choose in the open areas. However, it's pretty important to note here that the goal is that large parts of this process is still automated and reused, meaning that everything that the customer chooses will still lead to bill of material that is configured, but all the places where the customer leaves things open or add additional nodes, this is where the engineer would go in and do some extra work. So let's try to put all this into one big box. What's the starting point that we usually get from? The sales process in engineer to order is often a process that we find is fairly slow. It requires some very highly skilled sales staff to drive this process. And one of the challenges we've seen is that the output is often somewhat less structured. So we talked about the challenges with inaccurate orders. We talked about missing price information. We talked about potentially overpromised functions. So if we create an order in the engineer to order process, what happens is that this order will be sent to the engineering department for processing. And now the engineer would go in and look at the existing designs because concrete knowledge about the products is often described by the previously designed and manufactured products. So this knowledge describes specific solutions. It doesn't describe what is generally available and capable for the product. So now the engineer, he would start a search process, and if he's lucky, he would find an existing design that is a good starting point for the order that he's currently processing. And if that's the case, then a lot of the work might already be done. The engineer will now do a lot of calculations, and if everything is good, there's no missing information from the order as it's given from the sales department, there's no overpromise, then the final result of what the engineer does can be sent in form of a bill of material, possible other information, to the manufacturing system so that we can finally manufacture and deliver the product that the end customer wants. The different approach that we often want to get to is the configure to order process. So in this process, what we do is that we create a team that represents all the collective knowledge that we have. So basically, we want to make sure that we have all the departments that knows about the product, that are involved in defining the product, get that included in this modeling team. And the team will create two important pieces of information, two assets. One of them is the product model, and the other one is the configurable bill of material. The first step is to create this common language that we call the feature catalog. And using this common language, they can now interact with each other and capture all the knowledge they have in one place. What we want to sell, what we can technically produce, how it can be manufactured, service, etc. The second asset we create is the configurable bill of material, and that will capture all the possible parts and assemblies that could be consumed, and then be annotated with when each of these parts and assemblies should be used. The product model is now made available at the point of sale. So we have a sales configurator that's driven by this collective piece of information. I know today I've talked very much about using a product model at point of sales, but in reality, a product model is used in all the departments. So it's used everywhere where we need to inspect or work with the product. But today, the focus has been on how sales can create an order and get it to manufacturing. So the configurator will support the sales process, and that would give us a valid and complete configuration. And finally, having a valid and complete configuration, we can marry it with the configurable bill of material, and now we have all information we need in order to manufacture the product. So let's conclude on some of the benefits here. First off, for the end customer, we see a much smoother process, a sales process that is less prone to errors, and that just leads to a better experience for the end customer that is buying a product. The process is faster, it's more accurate, and you can actually trust what is being promised. A very important aspect of this is also that this whole process of configure to order compared to engineer to order, it requires fewer resources for each quote or each order that goes in. But I think most importantly is that we now, with a configure to order process, we get alignment between all the different departments. So we have all the collectives' knowledge in one single source of truth. And really, that is what CLM is all about. So this was a short run through of the process that a lot of customers have when they approach Configit, some of the challenges with this process, also some of the benefits, this flexibility we have, and then a suggestion for how we can move an engineer to order process into a configure to order process by introducing a product model and using the product model a lot of places, but primarily for this process at point of sale to get a much smoother process. So with that, I think my time slot is just about up. So thanks for listening, and I think I get the last slide here. Thank you.
Thank you, Anders. Let me see if we have any questions coming in. One of the things I've always wondered is how customers kind of accept or understand that their options are limited. Do you feel that like restrains the business at all, or does it kind of encourage more of standardization?
Yeah, it is a concern for some. If we take the end customer first, if we go straight from engineer to order process to a configure to order process, then some end customers buying a product might experience less choice. But remember, the goal here is to capture as much as possible for all the standard choices in the product model. So that means there will probably be cases where we cannot capture everything. And in that case, we still have to rely on at least partial engineer to order process. But the feedback we get is that having a configure to order process where the whole sales process is assisted by a sales configurator gives a much smoother sales process with better guidance and simply a faster track to the final order. And that is greatly appreciated by the end customers. The second part of the answer to this question is that I think if you look at the companies that are selling the products, they have to consider what to do if they still want to sell things that doesn't, you can say, fit the mold. So in that case, they would either have to have a separate engineer to order process or a mixed engineer slash configure to order process. We've seen that done a few times with some of the customers. One approach that we've seen is that if there was a customer coming in wanting to buy something that did not fit the product model, so there were choices that the product model would not offer, then what they would do is they would simply gather those requests and then enhance the product model so that the sales department can come back and now use the product model in the sales configurator in order to sell what the customer wanted. So that's one approach. We've seen another approach with another customer that would simply go in and have a capability to turn some of the rules off. Of course, they know that if you turn certain rules off, then you cannot give a guarantee at the point of sale. You would still have to send it to the engineer. But at least it would allow the salespeople and the customer to enter the requirements. So I think there's a lot of good approaches that will cater for this and make it possible to still offer the whole thing, everything that the company knows about, while still benefiting from the speedy process of having a configurator assisting the sales process.
Perfect. Well, thank you so much, Anders.